Hi, I've now got a third general purpose register, and I need to get this tested. First up, I want to confirm that R1 still is running the code that I had prior, and then I'm going to actually replace R1 with this piece of hardware so that I can test it and make sure that this now works properly. Then I want to go ahead and install a new register, and we'll call that R2, and create some code in order to test that. While I'm in the assembler working on creating some new instructions, I'm going to reorder the instruction set, which means I got to reprogram, rebuild all of my test code, but that will be easy enough to accomplish. I've already got that all integrated. Then I've got a couple of issues, time permitting, I want to get into and take a look at. If I can get to it, I want to get to the power supervisor and why it is complaining. And then I want to get into the control logic timing research. I don't have any solutions for that yet. And so I want to take a look at it and see if I can come up with exactly what my problem is so that I can then turn around and hopefully devise some kind of a solution. And if I can't devise a quick solution, then I will have to take it as homework and work on that in between videos. Finally, a little word on this. This does need to be dealt with in some way, shape, or form, but I am going to dedicate a video specifically to this. That'll be the one right after this. So the next video is going to be entirely dedicated to fixing the problems that I have here and getting it ready to go, because I can't go much further without one of these. Sorry about the microphone. I can't go much further without one of these. So let's get into our build. Hi, my name is Adam. I'm building a 16-bit computer from scratch. I hope you'll join me on this journey. Okay, so because I pulled out the register backplane in order to have a place to hold the pins as I was soldering up the last of this register, what I want to do is I want to first confirm that I've got everything hooked back up properly, and so all these connections here got reestablished properly, and that the circuit as it stands right now still works. And so this is the register 1 increment, decrement, increment, or decrement, increment, decrement, and then jump code. And that is working as it needs to be. So I'm going to go ahead and pop this out and put in my new register. And I have not applied power to it. I don't know what I'm doing here. Let's do this. Rather than pull that out, let's drop this in. And let's change the R1 register to be position C. It's as easy as that. So this is now R1. This is powered but not controlled. And this is the program counter. Let's try that again. Yeah, and there are some concerns here. So something is not, I've got a bit that's not working properly. Let me reset. Make sure nothing's hot this time. Okay, nothing's hot on the back. We've got one LED that does not appear to be working. So let me slide this way. Okay, I should be able to put ground here. I did have higher hopes for this. That looks like it's cross-connected here. That's an odd cross connection. All right, let's put this back in. I'm not going to push it all the way down this time. That one is bit 32. So back in diode mode here. All right, let me touch up those solder joints. We'll grab the digital microscope and we'll take a look at that. Okay, well, this fool forgot to hit the record button. What I found was for the LED for 32, it was floating on this end. And so I was able to melt the solder on this end, get it to sit flat, and then re-solder this end to it. Now, I do need to pull this out, which is what I was trying to avoid. And the reason that needs to come out is because these LEDs all lit up, indicating that there was some signals that were being assumed here. and pushing data out onto the bus, which is not a good thing. So let me plug this in here and we can give that a try again. Okay, something's floating. All the lights lit. There's my move. There's my value, which got moved into R1. I believe that's a decrement, and that is. I believe that's an increment, and that is another increment, and a third increment, a decrement, and a decrement, and then an assert, which should cause it to jump there. That turns into a no-op. That appears to be working just fine. So other than the LED, everything else on this appears to be correct. I got into the assembler and I started making some modifications to support the new R2 register and kind of position things for future changes as well, and quickly realized just how out of control this was going to get. So I've made some pretty significant changes to the assembler's parser in order to simplify things a little bit. And the big change here is that I am now implicitly defining all the conditional execution suffixes that can be added onto the end of an opcode. And so if there's nothing, then 00 will be used as the conditional execution, and each suffix that can be added onto the end of an instruction is laid out in the 4 bits here. And so each of those are 4 bits long. I also have, well, I've put in my R2 register, but I've also added, as I intend to also have a read-only Z register containing the value 0. And effectively, that's going to be available when nothing is asserted onto the main bus. There's going to be pull-down resistors in order to force a 0, effectively, out onto the bus. Okay, so I've prepped for that a little bit. But then you can see I have, for the 12 bits of instruction, the first 16 are the no-op. This is the only one that's actually hardwired into the system. And then I've got move R1, a 16-bit value after that. The instruction for the move into R1 of an immediate value becomes 001, and then the immediate value follows immediately behind it. And I've got the same thing for R2, and I have stubbed out and commented out additional moves that I plan to support, and then I've got a couple of holes here that I will use to fill in with other instructions as I find things that are onesies and twosies that can fill in these gaps. To make these changes, there was a pretty big overhaul of the code. I want to make sure that everybody understands this code's all available out on GitHub, even though it may change significantly yet, even though it's not 100% what I would call a final iteration. I want everybody to have access to it, and if you've got any suggestions, of course, leave me a comment or open an issue in GitHub. So with this, I did start looking at porting some of this from C to C++ code. And to do that, I also changed my parser from C to C++, where now anything that's external, I have to use external C in order to de-decorate or de-name mangle the specific functions. And then I've got the code that actually handles all of my different conditions. And so if I have conditionals that have been included in the architecture file, then I'm going to go ahead and add all of those different conditions for the opcode that I just parsed. Otherwise, I'm just going to add the individual opcode. So if going back to the architecture file, if none of these condition directives are included, then conditionals is not initialized and I'm dealing with individual opcodes. There's also a condition C++ file, and this just contains some functions from the classes that I've added. The classes are here. There is a condition which can be a prefix condition or a suffix condition, and then my conditionals becomes a singleton instance specifically related to managing all the different conditions that can exist. This class is specifically in place to hold this information. The rest of the changes are really pretty minor, a lot of it related to some cleanups to some debugging. For example, errors, I had to make sure that I flushed the file AO immediately after the error was written to make sure that it ends up on the screen correctly. So that then allows me to update everything, to get my assembler now handling these conditionals a little bit better. Something that's not going to explode this thing into hundreds of thousands of lines overnight. And I'm teed up a little bit better for the future. Okay, before I get into testing, the last thing I needed to do was to make sure that I updated the control ROMs to reflect all the new instructions, or at least the relocated instructions. And while I was doing that, I thought it would be prudent for me to remove the enum that used to be here. And I'll bring this up in diff so that you can see that. I wanted to remove the enum that used to be here and replace it with something that was generated by the assembler. That way it's always up to date. And then of course update my build so that I get everything building in the correct sequence. So the key then was to build opcodes.h. To do that, I made a change to the parser. So to output this enum, and to build this enum, that was done in, where is it, opcode. So that I basically have a string. As I come across each unconditioned opcode, I output it to this string. The string's 16 pages long, so I should have plenty of room to be able to do that. And then at the end, I output it to opcodes.h. And then I have it formatted in such a way that it actually can be read in as a header file, as a C header file. Now this is very hacky. It's very not optimized. It's very brute forcey trying to get through this, but it allows me to get through outputting that. So with each opcode definition that I parse, I add that definition to that string. So that allowed me to update everything. I now have in my control ROM and opcodes.h, this is the end result of that. Anything that is not a letter or a number gets translated into an underscore as I'm writing it to this enumeration. So it doesn't look fantastic, but we'll be okay with this. And then ultimately down here, that allowed me to have each individual opcode and make sure that I've got them all covered. All right, I've got several EPROMs I need to program. I need to give this a test, make sure that I didn't break anything. I have to go through each of those tests. Rather than subjecting you to all of that time, I'll do that off camera and only come back if I find anything interesting that needs to be debugged. If not, the next thing you'll see is me doing some work on wiring up R2. Okay, while this is playing up here in the corner, I did come across some timing concerns in some of the tests that I did. And what ended up happening was the latches weren't taking place consistently. The first few latches would be out of time or wouldn't take place, but for want of a better description, once the circuit warmed up, it did start behaving properly. And even when it looped around and went back to the beginning and executed that same code again, everything worked. So I've got something going on here that I need to get to the bottom of. And I need to do that before I can really move on and do much else. I could, of course, plug R2 in and kind of gloss over the problems and write some code to test R2, but I really think I'm reaching a point where if I don't get to the bottom of either power or timing or both, I'm going to end up with quite the concern here. So let me get the scope out, let me get the digital multimeter out, and let me see if I can figure out exactly what's going on here and why I'm having these issues. I'm not certain what I'm going to find as I start getting into it, so I don't know from here where this video is going to go. So stick with me, hopefully I can get to a solution here and at least stabilize this circuit. Okay. Let's start with a demonstration of what exactly the problem is. I've got the Larson scanner code in here, which means that R1 should have each light latch in turn all the way up to the most significant bit, and then turn around and latch in turn all the way down to the least significant bit. And it'll redo that, so it's going to be the Knight Rider effect. And I'll run this at a relatively slow speed, and what I would expect to see is that every light lights up in turn. And in the beginning, what you'll notice is there are several that actually get skipped, or at least if I can duplicate the problem, that's what you're going to notice. So I am in run mode. I believe I'm at a relatively slow pace. Let me plug it in. And you can see it skipped several of the LEDs here. Okay, I'm going to play this first test back again and keep an eye on the program counter. What I observe is that the first actual clock cycle that performs the unlatch dramatically changes the contents of the program counter. What I believe is going on here is that on power up, the counter ICs have something totally different than the latch IC has. And the first and latch that takes place is actually resetting or setting, if you will, the latch IC to have the proper value. And this goes back to power on reset. So let me play that back for you, and we'll kind of dissect this a little bit and dive a little bit deeper. I am not sure if this is the problem, but it is certainly a problem. Okay, that's enough messing around with slow-mo and zoom. So my reset circuitry over here is very simplistic. I have a pull-down resistor, which has a momentary push button on it, which would connect to 5 volts when you push the button. And when I push the reset button, it sends a reset signal to several components. It is resetting the program counter. It is also resetting the R1 register, but the clock is also latching. It is asserting, or it's actually turning off output enable on the program ROM. And I have pull down resistors here, which means that I am actually sending a no-op instruction here. Now a no-op instruction is decoded in the control ROM to also latch. And you can see here you've got the increment and latch that takes place on a no-op. Well, it's incrementing, but it's also remaining at 0 because it's in reset. R1 does not latch. That's a separate problem that I need to get to. Okay, when I release that, I start counting, and depending on where and how it's released, I may or may not get a good increment, meaning the first time I release it, or when I release it, it could count from, say, 0 to 2 or 0 to 1, depending on exactly the timing on when that's released. And I'm watching this as I record it, and it's behaving. I don't know that the first time behaved properly. That said, what I want to do is I want to test the power on, because it's the power on state over here that is non-deterministic. And it just happened to have worked that time, but it did not reset that time. So the simplest thing to do is to manually set that so it's as if I'm pushing that button with that wire there. I plug it in, the entire circuit's in reset until I pull that. And then my Larson scanner appeared to have worked properly. Let me do that again. That is all high. And then if I pull it out of reset, and that still did not latch. So I still have another problem. My reset circuit is a problem, but it is not the problem, and it is not what is causing this issue. Okay, I resorted to recording several tests so that I could go back and watch them and keep an eye on different things as I was reviewing the test results. And I pulled out some LEDs and plugged it into the address that's being presented to memory in order to read an address. And I came across something interesting. So let me just talk you through what it was that I saw. On reset, the address FFFE was being presented to the memory, which is okay, which is just some inconsequential address. Then after the first increment and latch, the address 0002 was being presented. And that's kind of what I was talking about before. The counters and the latch were being initialized to two different states, and therefore they could come up with something totally different. And then it started counting from there, 0003, 0004. So that's what I was able to observe in this particular test. Now, with that said, it could be that the addresses and the contents of what is being retrieved on those tests or at different points in time are not correct, and therefore in this particular set of code, what is being interpreted, what should be interpreted as a data element, is being picked up as an instruction. For example, if the first address that's executed after reset is address 1, then that is going to end up being a different instruction than the actual load instruction that I'm hoping to do. Let me see if I can pull something together to demonstrate that. Okay, after, well, several attempts at trying to record an explanation for this and several hours of video and lots of false starts, I believe I can duplicate this problem on demand, and more importantly, solve it on demand as well. Let me plug in power here. Now, I've got this currently in manual mode. This is my reset button. And when I push down on the clock here, the clock goes high, and then when I release it, it goes low. And so I can clock this a couple of times to clear out both my fetch register and my instruction register and make sure that my program counter gets latched to 0. With the clock in a low state, I release the reset, and then I start fetching, and you can see that the Larson scanner itself is working. Now, let's reset again. Hold down the reset button, clock a few times to clear everything out, and this time with the clock level high, I'm going to release the reset and then release the clock and then start clocking, and my first LED works, but my second does not. And you notice it jumps all the way up here, the third bit, starting from number 0. This tells me a couple of things. Number one, when I power up, and you'll want to keep an eye on these two LEDs here. The one on the right here is the inverted clock. The one on the left here is the normal clock. When the clock is lit, the clock signal is high. When the inverted clock is lit, the clock signal itself is low. So when I apply power again, I power on in the inverted state, which means that the first transition happens from low to high. And I believe it's the transition from high to low during the reset that is required for the reset logic. Well, that's good. As much as I'd like to say that I have to fix that in this video, the reality is I have been meaning to do something with this clock module and additional reset logic for a little bit here. So I'm going to take that on as the next video and get that resolved. It'll probably be a ground up rebuild of the clock and reset circuitry in order to make sure that I'm able to reset this circuit properly and not have to worry too much about it. All right, that said, I leave this in manual mode. I can clock a couple of times, reset. My R1 doesn't get latched, but then I can click this. Whoops, I'm resetting. I can click this manually, and I will go through all of the Larson scanner code. And that works exactly as it needs to. So that takes care of the, at least identifying the timing issue, but I do have some steps to do to solve that. Now that all that nastiness is at least identified and I know my steps forward there, let me go ahead and get my R2 register plugged in here and wired up. Helps if I put it in right side up. So that will be my R2 register. I don't need this output anymore, but I do need to add the control signals for R2. And I'm going to land these signals down here for the moment, right in line with the ones above them. And then I've got to get a few things plugged in here. First of all, my clear I want to tie together, which we realized it doesn't do everything that it needs to do, but we'll tie it together anyway for completeness. The next 3 signals need a pull-up resistor. 3 1K ohm resistors, and again, these are to kind of patch together the logic, the CMOS logic and the TTL LS logic, which have different high signal values. The CMOS or HC logic has a higher high threshold than the LS logic puts out. So if I'm not directly pulling it down, I need to be able to pull that up to 5 volts so that it registers properly a high value. Okay, my R2 assert to main is from O2 here, so there's 0, 0, 0, 1, and then 0, 2, and main is going to be this one, and that's the extent of changes on control logic 1. Control logic 2 had no changes associated with it. Control logic 3 had 2 signals that need to come down as well. Okay, bit 6 up here, which is there, is going to come down to the AND latch bit, and that's going to be the rightmost that has the pull-up on it. These 2 bits, or these 2 signals next to it, are coming up here to this NAND gate. Now, the point of this NAND gate is I'm going to use it as an inverter. Okay, this ends up being so totally wrong that I need to just cut in here and go straight to the correct wire up. And these signals really need to model after what's going on here in control logic 2, which means I need an AND gate, not a NAND gate. And it's not a double inverter or anything like that, which is what I was thinking I needed to do up here. I've got room on this board because this is totally full, which is why I had to move the signals up here to logic 3. And so what my plan here to do is I'm going to actually slide this inverter over until I can get to the root of this problem. And I'm going to insert another AND gate here so that I can tie this all together. Let me start that. And then the new AND gate here, make sure that it fits. Get decoupling in here, since this one's going to be a more permanent feature. Now the outputs that go off to my control signals are actually going to be the outputs from the upper AND gates here. The inputs, one will be the signal, and the other input here is going to be, it's going to be the clock, which I can take from here. So I can take one signal from there and chain it from there over to there, and then these can go away. I don't know why I needed new wires. So that is far closer to what is required here. Okay, I think I'm ready to write some code to populate this. Oh no, I'm not ready to write code for that yet. I do need to tie several of these high. Now I can write some code to give this a proper test. Okay, a quick tour of the code here. I've got 4 instructions that I need to test related to R2. The first is moving an immediate value into R2, and I do that several times as I go through this test. The second test I need to move the value of R1 into R2. I do that a couple of times as well. I need to move the value from R2 into R1, and I test that as well. And then finally, I need to jump to the contents, to the address that's held in R2. Those are the 4 distinct tests that I need to execute. And then, of course, I've got this code set up that it loops back around, and we can iterate through that a couple of times. Let me get this onto the EEPROM. I'll stick the code up here on this side so that you can follow along, and with any luck, I won't have to replace that with the issues list because everything will work properly. What are the odds? All right, well, I've got this in manual mode still. Let me apply power. and perform a proper reset sequence. And my latch signal here is high. And latch is coming from this signal up here, which should be pulling low. This is the signal that needed to be inverted here. So it needs a double inversion in order to get the right timing. So I need to pull this signal over here for a double inversion. Or do I have that wrong? I have that wrong still. So it should be inverted and then NANDed together before it comes down. Okay, inverted twice. So invert, invert, and then the output here is NANDed with the clock there and then there. Okay, let's try that. That's better. Again, reset. There's move, value 1 into R1. There's another move, value 2 into, that's not right. Let's move into R2, and then here is the value that gets moved. That's going into R1. Let me reset again. Move, value, move into R2, and that didn't advance. And go back to the control ROM code and find out what's going on there. Well, it's amazing the mess a single character can make. This is the move into R2, an immediate value that's 16 bits long, but I'm loading and latching R1, and that's not right. That should be loading and latching R2. So let me get that cleaned up and reburn the appropriate EEPROMs, and we'll give it another test. Okay, let's give that a shot and see how that works. Again, reset. And then move of an immediate value into R1. There is, nope, that hasn't moved up yet. Nope, there's that value. Move of an immediate value into R2. And then when I release the 8, it should move into R2, which it did. Good. Move into R1. Value 2. And then I am not familiar with that one. That should move the value of R1 into R2. So this bit should turn on, that bit should turn off. Okay. Clock it and release. There it is. Now I'm going to move into R1. Move into R2. That's correct. Move into R1. That's the value. Move into R2 from R1. Then move into R1. That's the value. So move into R2 should be 800. Yes, there it is. Now I do a move of R2 into R1, and next instruction will latch that, and that's correct. Then move into R2 all zeros, and then my jump to 0. And that resets my program counter, except I don't know that I fetched the correct value. No, that's actually working correctly. It looks incorrect, but it is working correctly. I'm getting the correct results anyway. Okay, I'm pretty happy to have that working. I won't lie, I wasn't sure that I was going to be able to get the R2 register fully working in this video. The challenges around reset and the clock are significant, and I am going to pause here, if you will, and take some time to get any known issues resolved. Once I add the ALU adder into the mix, there's going to be a number of issues that crop up from that as well. It's a pretty significant bump in complexity of the circuit, and I want to make sure that before I get to that point, I've got all issues resolved that I know about. That way that process is, as I hope, pain-free as possible. I'm not sure if you noticed or not, but I wasn't comfortable with the timing of those instructions in that last test. And while I declared it a success because I got the results I wanted, I don't know that it is necessarily a complete success. So I am going to spend some time off camera putting together a timing chart that I can keep at my side for reference and make sure that things are happening the way that I expect them to. Specifically, I lose track of what's supposed to happen on the high side of the clock cycle and what's supposed to happen on the low side of the clock cycle. And as I'm on camera trying to explain it, it becomes ever more difficult for me to continue to keep those things straight in my head. So I need a cheat sheet. That's all it boils down to. So I'm going to spend some time off camera working on that so that hopefully I can articulate things a little bit better in future videos. I keep looking down because I've got the circuit running right in front of me. It's distracting. So let me unplug that. So with that, look forward to the next video where I tackle a complete rebuild of the clock circuit and the reset circuitry and try to make sure that I can always get a proper reset of my circuit. We'll see you soon.